Okay, I think this is recording. So, yes. Yeah. So I'm gonna try to finish this up real quick. All right, so yeah, we did that one already. So, all right. So signs of infection. So how would you know if you had a blood infection? If we sent you in for a CBC with differential, like how would we know? Hold on 1 second, guys. Let me hit share. Yeah. Okay. Yeah. So how would we know? CBC with differential. Well, leukocytosis, white. Leuko means white. Cyto means adult cells. Increase in white blood cell. But we don't know whether that's neutrophil, basophil, eosinophil. We don't know what it is. All right. Leukopenia is decrease in white blood cells. So generally, if we have a decrease in white blood cells, we probably have an elevation in red blood cells or something else. And one would indicate a bacterial infection, and one usually indicates sometimes a viral infection. But we're guessing until we actually do a blood draw really and figure out what's going on. So septicemia is microorganisms are multiplying in the blood and present in large numbers. That's never a good thing. Bacteremia, obviously it's bacteria multiplying. Viremia is small number of viruses present but not necessarily multiplying. And then I think we talked before about or I posted it, maybe it's coming up, about interferon and how if you have a viral infected cell, it's going to send interferon to the area and tell the other viruses, well, listen, if you come across this, we want you to go through apoptosis so you don't become a virus producing factory, right? Asymptomatic is subclinical infections, although infected, the host doesn't show any signs or symptoms of the disease. So people can have typhoid mare, it was asymptomatic. People have walked around with corona SARS-2 or all these different flus or whatever viruses have been asymptomatic, had no signs or symptoms other than maybe a small headache, cough, nothing. There would have no obvious signs or symptoms. In apparent infection, so a person doesn't seek medical attention, because you're not going to go to the doctor and go, I feel great. I just thought we'd come and chat. People aren't going to go seek medical attention unless there's really an issue. Unless you're doing a follow-up, obviously. But portals of exit. So remember, the portal of exit doesn't always have to be the same as the portal of entry. Respiratory mucus, sputum, nasal drainage, saliva. All right. And there should be a video coming up with someone sneezing. You can see the air droplets and the aerosol droplets and how far they can go depending on the wind and how small the particle is. So skin scales. All right. Fecal exit, more common than we think. Urogenitals tract and removal of blood. So we're talking about hepatitis or something like that. Right. So apparent recovery of host does not always mean that microbes are removed. So you can recover, you can become asymptomatic, but that can always regenerate or can always have a flare-up. Latency after initial symptoms in certain chronic diseases, the microbe can periodically become active and produce a recurrent disease, and that's common with HIV and some of these other, even hepatitis. Right. Chronic carrier is a person with a latent infection who sheds the infectious agent. Typhoid Mary, fecally, didn't wash her hands. She was a cook and she just spread it from her fingernails, and I don't want to think about it. Sequela, it's a long-term or permanent damage to tissues or organs. And usually if you have a disease, there's always a sequela that follows that. So you can have disease A, B, or C, but you can always say the sequela with that is always, or, a heart attack. Sequela is myocardial damage, and then it becomes respiratory damage, and then it becomes kidney damage, or if you have certain emphysema or certain even pneumonia can cause a sequela of lung damage, permanent lung damage too. All right. Reservoir is primary habitat of pathogen in the natural world, so it can be human or animal carrier, soil, water, or plants. And if we're talking about SARS or COVID, whatever, there's a big theory that was zoonotic and it was laboratory genetically modified, from a bat to be able to genetically modified to be able to get into the human cell that has angiogenesis converting or converting enzyme, angiotensin converting enzyme receptors, anyone with an ACE receptor. It was designed to be able to attach that. Normally, in a bat was zoonotic, our cells wouldn't have been able to attach to our cells or get into our cells, but it was genetically modified, so they say. Source is individual or object from which an infection is actually acquired, and we'll get into Koch postulates and how they was able to prove that a certain specific organism caused a very specific disease. Right, you could trace it back to the source. Right. So living reservoirs can carrier, an asymptomatic carrier or a passive carrier. A lot of us, could be a passive carrier with a stethoscope or a tie or even a pen or something. Contaminated healthcare provider picks up pathogen and transfers them to other patients. And, that's why now, you have to sanitize your hands. And when I first started to practice, I would always iron my ties just to make sure that everything was killed on, so I wasn't inadvertently touching patients with the tie or whatever, transferring. That would be passive carrier, and it would be a nosocomial infection because that person got it in the healthcare setting, right? Incubation carriers spread the infectious agent during the incubation period. They don't even know they have it, right? Convalescent carriers, they think they're fully recovered, but they're still harboring some of it. They cough, sneeze, share utensils, make a meal, whatever. Chronic carrier, individual who shelters the infectious agent for a long period, and they may be chronic and asymptomatic, right? So anything's possible. Vectors, all right, these are major vectors. So vector, like in physics, is point A to point B. So generally it's something that you think is more linear, or something that's carrying something. And they can be an inadvertent or a non-biological vector. So they could carry it and not be affected at all by it, or they could be harboring it, they're affected by it, and they transfer it, or the vector is not affected by it at all, right? Biological vectors actively participate in the pathogen's life cycle. So they have something, trophozoite stage, or if you're talking about bubonic plague or something, that flea is going to, their esophagus is jammed up, they get ravenous, they bite anything that comes along, and they're inadvertently giving you Yersinia pestis, but it doesn't affect them at all other than blocking up their esophagus. Mechanical vector is not necessary to the life cycle of the infectious agent and merely transports it without being infected. So they just literally transport. They have no contribution other than transporting that bacteria or whatever it happens to be. All right, zoonosis, an infection indigenous to animals but naturally transmittable to humans, is a zoonotic. All right, as far as I can tell, I'm not saying 100% right, but COVID was not zoonotic. It wasn't something that a bat could transfer to us. This was genetically engineered to do that. All right, humans don't transmit the disease to others. At least 150 zoonotic exist in the world, making up to 70% of the new emerging diseases worldwide. And we have to remember that's because we're invading the rainforest. We're in areas we should never be. And if you're driving anywhere you go, they're constantly building in forests and tearing down wildlife areas to build houses and things like that. All right, it's possible to eradicate the disease without eradicating the animal reservoir. And we have some reservoirs, but if let's just say hypothetically it's a raccoon on one, well, we kill all the raccoons, this thing could go to a chip or to a woodchucker. I'm just saying, like, it would be impossible to eradicate all the animal reservoirs for certain diseases, unless we're talking about like leprosy and possums or something weird, where they'd be the only yeah, plague, rodents and fleas. Is it on here? Ringworm, Rocky Mountain spot fevers, ticks, rabies, all animals. thought for sure it'd be up there. Bubonic plague. Or armadillos. Sorry, these are possums. It's armadillos. Never mind. I misspoke. Communicable diseases, when an infected host can transmit the infectious agent to another host and establish infection in that host. Highly communicable diseases are contagious. All right, so this is something that we can spread host to host, like, you know, don't want to use SARS and COVID or whatever, but non-communicable infectious disease does not arise through transmission from host to host. Occurs primarily when a compromised person is invaded by his or own normal microflora. Contact with organisms in natural living, non-living reservoirs. This isn't something you transfer host to host. Not communicable. All right, direct contact. Indirect contact passes from indirect host to intermediate conveyor and then to another host. A vehicle, that can be a fomite, inanimate material, food, water, biological products, fomites, latex toys, or, you know, whatever we're talking about. And airborne, droplet, nuclear, aerosols, and these are pretty much invisible. I think I had a video of this somewhere. I don't know. I think they took it off of YouTube, but you could watch this and you could actually see, they did suspend an animation, you could see how it moved. And it went like a quarter mile. It's crazy. Here, I embedded this, so it should work. Embedded it twice, once regular, and then once I just did it with the new MacBook way of doing it. So hopefully that'll work. All right, so please watch that. It's on there twice, so maybe it'll work. Oh, 3 times. Oh, 4. Okay, so how communicable infections diseases are acquired. I'm just going to show you direct and indirect. Okay. So these we're pretty much we're sure of. These we don't think about so much, right? So doorknobs, cooking, sneezing or sniffling or whatever. And then, you know, rodent urine or feces or, you know, whatever. And even if you're in an attic or basement, these rodents can urinate on certain things, it dries, and you could pick it up. Nosocomial infections, diseases that are acquired or developed during a hospital stay. This can be a waiting room, it can be a hospital, it can be the elevator, it can be a doorknob, it can be a cafeteria. All right, so you pick up something, and by the way, you're going to pick up a really good disease in a hospital, nosocomial. You're not going to pick it up. You wouldn't generally pick it up in the general population. You got to go to a hospital where they have all the best germs, right? From surgical procedures, equipment, exposure to drug-resistant microorganisms. So whenever I go to the dentist, I'm always freaking out about the equipment. Or when I had my shoulder surgery, I was petrified of being cut open and, you know, God forbid, getting a nosocomial infection. Okay. And then universal precautions, we should all be aware of that. You want to treat everyone as if they have a blood infection or something. Be the cleanest person in the world, you know, unless it's your spouse or your kid, you know they don't have something. You treat every person as if they have hepatitis, HIV, or something that's highly communicable and highly pathogenic. Right. All right, so epidemiology. You know, we really want to, if we have something come up, we really want to be able to trace where it came from. So you have to start figuring out what, as bizarre as it is, what are these people that have this, what do they have in common? So if you can watch the movie Contagion, it's like 2 hours long or whatever, but it literally was designed by epidemiologists in New York, and it literally is very similar to what's going on right now. It was zoonotic, and I won't tell you how, but you don't know to the very, very end, but you can see how these things were transmitted across the world on the airport, on glasses, credit cards, doorknobs, subways, just the crazy way that this can be transmitted. So these are all terminology from before. So prevalence, incidence, mortality rate, and morbidity. Mortality is the total number of deaths in a population due to a certain disease. Morbidity is the number of people afflicted with a certain disease. So the morbidity rate is always higher than the mortality rate, but this is just how many get killed, how many people have it, or we're talking about comorbidities with the diseases now. Like what else do they have going on? All right, incidence is the number of new cases over a certain period of time as compared to the general healthy population. So with, the incidence is rising, or the prevalence is the total number of existing cases with respect to the entire population. So what is the prevalence of a flu in, all right, I probably shouldn't use that now, but the flu in January normally wouldn't be that prevalent because everyone's outside, we're social distancing anyway. But what's the prevalence of the flu in December, January? We're all in the same quarters, or before the current situation. All right, incidence, the number of new cases. So every new incidence of it is a number of new cases over a certain time period. So the incidence of all right, so let's say the incidence of bubonic plague in Orchard Park would not be very high, and the prevalence wouldn't be very high, general population. But we're talking about the prevalence of cholera in rural China, probably huge, right? And there's just another difference between endemic. So these are like idiomycosis, idiococcyomycosis, San Juan fever, all right, is very, very endemic here, but it wouldn't be endemic in New York. The temperature is different. Right? Sporadic is when occasional cases are reported at a regular interval. So if we had a sporadic case of measles, we would have to say, well, it's not really prevalent. So somehow these cases would all be related at some point. Now we want to call on the CDC, figure out, well, how did this could be patient one. How did this person contact it from this person? Or if we had one or two people had it on a plane and they infected everyone, or they were on a cruise or something, we'd want to figure out. It's sporadic, but it had to come from somewhere. It didn't just spontaneously generate. Right. Epidemic, when the prevalence of a disease is increasing beyond what's expected. Right. And pandemic, I won't even use that word now. All right, so just be familiar with Cox postules, determining the causative agent of disease. So here's the whole, find the evidence of a particular microbe in every case of the disease. Then you have to isolate that microbe from an infected subject and cultivate it artificially in the laboratory. So it's taken out of the organism. Then you have to inoculate a otherwise healthy individual. That or that subject has to die from it, and then you have to be able to re-isolate that agent from the subject. Now you know that that specific organism caused the disease. Okay, I'm going to pause this. I'm going to process this, and hopefully I can pop this up on YouTube shortly here.